going to do chemistry, introduction to acids and bases. Does anybody know what is an acid or a base? Anyone? Christina?
I'm not sure, but I think I remember something about hydrogen ions being with an acid. I don't know if that's right.
That is right. That's exactly right. That's a lot more than I thought you would know though for grade 10. But good. Anybody know what a base is? Sadia?
I think it's something which has high pH value.
That's perfect. We're going to talk about pH towards the end of our lesson a little bit later. And actually you guys are going to have a lab in a couple of days where you guys get to test the pH of some household items. Okay? So, I'm actually going to give you the definition of what is an acid and base that you guys need to know for your test. It's on your handout in front of you. Erica, can you read it for me, please?
Acids and bases are types of compounds that behave similarly, especially when dissolved in water. Solutions of acids are often called acidic, while solutions of bases are often called alkaline. Acids and bases can be weak or strong depending on their concentration.
Very good, thank you. So just like Sonia and Christina said, an acid is also a compound that produces hydrogen ions when dissolved in water, and a base is a compound that produces hydroxide ions when dissolved in water. So how do we know if something is an acid or a base? Just without knowing, if we don't know what a chemical is, how do we find out if it's an acid or a base? Anyone?
I think maybe acids, they have like strong smell. Like you can smell them.
That's a good idea. But a lot of acids don't have any smell. Anyone else? Well, how we find out is we actually have special chemicals that are called indicators. And they're called indicators because the color they change when they react with an acid or base changes. So some of the ones that we're going to use in our lab in a few days are litmus paper and phenolphthalein. Litmus paper is a special kind of paper that when you place in an acid, it turns red, and when you put it in a base, it turns blue. So you can really tell whether it's acid or base. And phenolphthalein is a chemical, it's a liquid. When you place an acid in it, it actually turns reddish pink. And when you put it in a base, nothing happens, it stays colorless. I mixed it up, it's the other way around. It actually turns red with a base and colorless with an acid. So just go by what it says on your paper in your textbook. Okay, so now we're going to talk about some properties of acids and bases. Their properties means that they are kind of all the same, similar properties. Just like in a previous lesson we talked about how we have nonmetals and metals. Acids and bases is kind of another way of grouping certain kinds of chemicals. So they have similar properties. Okay, so acids have usually a sour taste. Can anybody think of some sour acids that they know of? Sorry?
I think orange, maybe it has citric acid, that's why sometimes it's a little bit sour.
That's true, that's right, perfect. Christina?
I also find lemons have a real sour kind of taste to them.
Of course, of course. It's because they also have citric acid. All the citrus fruits have citric acid. Actually, citric acid is actually found in a lot of foods. If you look at the ingredients, you'll often see citric acid as one of them because they actually use it as a preservative. So it's very common. They're also water soluble. They're good conductors of electricity, and they react with metals to produce hydrogen gas. Okay, so that's another lab that we're going to do this week, where you're going to be able to see that. Now on to bases. Bases are not, people don't usually know too much about bases because they're just as common as acids, but they're not called bases. They have different names. So I'm going to tell you about some of their properties. They have a bitter taste. They feel slippery when dissolved in water, and they're good conductors also of electricity. Now, one thing I forgot to tell you before. We never ever taste an acid or a base unless I tell you to taste it in lab, because there's a lot of acids and bases that are very poisonous if we ingest them, even in small amounts. So never taste them, okay? Good. Okay, so I want you guys to look at your sheet and look at some of the common acids and bases so you can get familiar with some of them. And these are some of the ones that we're going to have in our lab that we're going to be working with this semester and next year if you guys take chemistry. Okay, so we have vinegar. Nobody mentioned vinegar. We have citric acid. Vitamin C, that's actually an acid. Did anyone know that? No? Lactic acid is something that our bodies actually produce naturally. Carbonic acid, acetylsalicylic acid, ASA, is found in aspirin. And sulfuric acid is found in carbonates. Now, does anybody know any bases without looking at your sheet? Sorry.
I think baking soda.
Yes. Baking soda is a common base. Anybody else?
Aren't Tums a base?
Can you
Tums, the Tums heartburn pills?
They are. And do you know why?
Because
take those?
the acid in our stomach is being pushed up our throats, and to combat that, I guess, you have to have the opposite. So I would only imagine that they would be a base.
Very good, Mike. We're actually going to be moving on after this to neutralization reactions. And although that's not exactly full neutralization reaction, that is kind of what's going on there. So very good. So if we look at some of the bases on this sheet, we have sodium hydroxide, potassium hydroxide, aluminum hydroxide, sodium bicarbonate, and potassium sulfide. Does anybody see anything common with some of the bases, how they're named? Christina?
Is it maybe that they have BOH?
That's right. So often how you can tell if something is a base is if you look at its chemical formula, it has the OH in it. But that doesn't mean it's always a base. There's a lot of things, like if you look at the sodium bicarbonate, it doesn't have OH, but it's still a base. That is because when it is put in water, it produces hydroxide ions. If you go back to the definition I gave you. We'll learn more about this in detail in our next class. So now I want to move on to how we measure the strength of acids and bases. Sadia already mentioned that we have a pH scale to measure the strength of an acid or base. pH actually stands for power of hydrogen. Because remember, the strength of an acid is determined by the concentration of hydrogen ions. So the more hydrogen ions we have, the stronger or weaker acid.
Stronger?
Right. Does anybody think it's weaker? No? Good job, guys. So I'm actually going to try it. I'll try it over here. Our pH scale. You guys have a picture of this in front of you. I'll just try it again. So the pH scale is kind of like a thermometer, but not exactly. It's similar to that. It measures how basic or acidic something is. So here's 7 in the middle. That would be neutral. It's neither acidic or basic. 0 over here, anything this direction is acidic. Anything greater than 7 is basic. And we're going to learn next class how we actually calculate that. If we know what the hydrogen concentration is, we can find out what the pH is. Can anyone tell me what the formula is from your sheet? Erica?
pH formula? It is pH is equal to negative log of hydrogen.
That's right. Okay, so you guys have a worksheet now that you can work on. which you'll have to hand back at the end of class. Okay?